eDay number 3, solving rational equations. Here's a little video to help you with that. These are called rational equations because we got an equation with some fractions. Fractions are also called ratios. That's why they're called rational equations. The goal when we're solving these things is to get rid of the fractions. You folks have been solving equations without fractions since 7th grade, and you're very good at it. So if we can somehow make the fractions go away, this will be a super easy equation to solve, okay? Now, the very first thing to do even before that is anything that's a binomial, let's put those in parentheses, treat them like one term. So x minus 6, x plus 5, and the x plus 6. Those all get parentheses. Okay, so to get rid of the fractions, we want these denominators, or the bottom of the fractions, to go away. And how we can get them to go away is by maybe multiplying something on the top so that we can get a cancellation on the top and bottom of the fraction. And whatever we do to one fraction or one side of the equation, we'll have to do to the other side and all the terms involved in that side. So as I'm trying to decide what to multiply by, I got to get rid of this 2x squared here. So I could multiply by 2x squared here. And I know I'm going to end up doing that over here. The only thing is, if I imagine multiplying by 2x squared on here and on these, I'll have a 2 up here, and a 2 and a 4 don't quite cancel. 2 over 4 would be like 1 over 2. So I could multiply by 2, but I'd rather multiply by 4 so that I can get them to cancel here, and I can get 4 over 2 here, which will cancel to 2. Now when I look at the x's, I need at least 2 x's, right? Because if I just multiply by 1x on all the terms, x over x squared won't cancel. So I need an x squared. This process here is called finding the least common multiple of the denominators. We spent some time on that in class. So the least common multiple of my denominators, the least common multiple of 2, 4, and 4 is 4, and the least common multiple of x squared and x is actually x squared. It's called the least common multiple, but really we want the highest power of x so that we can get everything to cancel. So I'm going to multiply everything by 4x squared. One term on the left and the 2 terms on the right. All right. Then we can ask what cancels. Okay, on the right, I got 4x squared and 2x squared. Well, I know the x squareds will cancel, and 4 over 2 is just 2 over 1. 2 over 1. Okay. X plus 5, 4x squared over 4x. Well, the 4's cancel. X squared over x, I've got 2 x's here and 1 x here. It means I'll be left with 1 x on the top. So just a 1x right there. Same exact thing here, right? 4's cancel. X squared over x is 2 x's over 1x. I'll be left with 1x in the top. So when I go to bring down, I've got a 2 here, x minus 6, and nothing on the bottom besides a 1, and I don't need the 1. So 2 times x minus 6. Okay. Here, both things on the bottom cancel, so it's just left with an x, so x plus 5 times x. X plus 5 times x. Same thing here. X plus 6 is left with an x as the only other thing, minus in front. Minus x plus 6 times x. All right. You are all probably good from here. Distribute the 2. I get 2x minus 12 equals, now this x has to be distributed. X times x would be x squared plus 5x minus, well, again, one term next to 2. Distribute this x. Distribute it here too. Okay, minus x squared. That's a positive 6x, but there's a minus in front. Minus 6x. Okay. So, still got 2x minus 12 on the left here. And on the right, x squared and negative x squared. That's like saying 3 minus 3. Those cancel. That's 0. Those cancel. 5x and minus 6x. 5 minus 6 is negative 1. 5x minus 6x is negative 1x. Okay, let's Let's get all our x's to one side, all our numbers to one side. Move the 2x over. Subtract 2x from both sides. On the left, negative 12 is left over. Negative 1 minus 2, negative 3x. Divide by negative 3. Looks like we're getting 4 equals x for our answer. Okay. Just like radical equations, we want to check to make sure this answer works. And really, the only check we have to do is to make sure that we don't get 0 in the denominator if we plug it back in. 2 times 4 squared, that's not 0. 4 times 4, that's not 0. So we're good. X equals 4 is our solution. Okay. If we had a problem that looked like this, x minus 6 over x minus 4 equals yada, 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 and I got x equals 4 as an answer, if I were to go plug that back in, I'd have x minus 6 over x minus 4 would be 4 minus 6 over 4 minus 4, and that's something over 0 in the denominator. Can't divide by 0, then that'd be an extraneous solution. So you want to check to make sure you don't have any of those 0 in the denominator. But our answer of 4 in this original problem doesn't give us any 0 in the denominator. Okay, so that's an example of solving a rational equation. Try to get rid of the fractions. You're going to have to multiply all the terms by the least common multiple of your denominators so that there's no more fractions and you have something easy to solve. You might have something like this after you're done canceling. Let's say an x squared, a 7x, and a 10 equal to 0, right? It's possible that when you solve this, you'll have to do an x game if you have a trinomial. 10 on the top, 7 on the bottom, and then you go from there, okay? So you could either have sort of linear equation like this or a quadratic, a trinomial. Either way, this part isn't the hard part. The hard part is figuring out what do I have to multiply by to make the fractions go away, and then the rest is not too bad. Hope that helps. Let me know if you still have any questions.